Hello all, my name is Mark, I'm a PhD student, and I'll be presenting Synchrony and Triads in Virtual Reality. In common face-to-face interaction, we exhibit nonverbal behavior. We nod, gesture, shift our weight, step forward, and lean back. There are many ways to break up and break down these nonverbal behaviors, and one approach is to extract body motion over time. The amount of motion that interaction partners have is statistically correlated. The correlation is small, but consistently positive. This is interesting in itself, but becomes more interesting that this correlation of motion over time, this synchrony, is itself related to outcomes, such as task performance, prosociality, rapport, mother-child bonding, and cooperation. So, in short, synchrony is of interest to researchers studying teams or social behavior more broadly. But how is this motion data collected? This is where virtual reality comes into play. VR needs tracking data, usually head and hands position and rotation data, in order to display content and support interaction. It is not hard to capture this motion data while participants use virtual reality. Virtual reality also affords experimental manipulation of the setting, with much greater flexibility and lower cost than real-world settings. To our knowledge, the study we present is the first to manipulate the environment of a team and observed its effect on synchrony. This work's contributions are new methods for measuring triadic synchrony, confirmatory results that synchrony occurs between teammates using virtual reality, confirmatory results that synchrony occurs among triads, evidence that the virtual environment can influence synchrony, a proposed method for measuring synchrony in subsegments of time, evidence that speaking roles influence synchrony, and evidence that gaze influences synchrony. Now, let's describe the study in more detail. The independent variables are set up in a 2x2 design, with one variable of task, decision-making or concept generation, and environment, conference room or garage. Here's a video capture from the perspective of participants in the study.
Navigate that way. So
Okay.
So it has to do with more balance and, again, that ingrained intuition of how to navigate.
to steer.
Yeah.
So it should have a steering.
The VR application we used to network participants was named High Fidelity, and the VR technology, the headset in use, was the HTC Vive. One measure we'll spend time on is synchrony, because in addition to environments, this work is one of the first to look at synchrony in triads. Normally, synchrony is computed among two participants. We can leverage this measure into a measure of triadic synchrony we represent with sync subscript average by focusing on two participants at a time, computing the synchrony between them, then taking all these correlations and averaging them into one number. This works numerically, but can we really justify treating this three-person interaction as three two-person interactions? In some sense, we can. We show that this measure is linearly equivalent to a second measure that is more holistic. In this second approach, variance among all participants' speeds are measured. If the variance is large, the participants are not in sync, but if the variance is small, then the participants are in sync. By computing 1 minus the average of the variance across all these moments in time, we have a second measure of synchrony that we call sync subscript T-var for variance within time. Surprisingly, we show that these two methods of measurement are essentially equivalent. More specifically, these values are related by a linear function. The result is not obvious, but it is not difficult to show. It is related to the law of total variance, and a proof is given in the supplementary material of this work. For this study, we'll be using the first, the average of pairwise correlations, sync average, because it is evidenced in previous literature and it has the nice feature that independent signals have synchrony 0. Now that we've established the experiment, let's talk about the results. First, synchrony occurs among triads in virtual reality. Here you can see a peak of synchrony around an offset of 0. The pseudo-synchrony test was strongly significant and the p-value was less than 0.001. To our knowledge, this is the first evidence of triadic synchrony in virtual reality and corroborates a handful of papers on either triadic synchrony or synchrony in virtual reality. Next, we look at synchrony based on our independent variables. We did not find a difference in synchrony based on the design task. However, we did find a difference in synchrony based on virtual location, such that when a triad was in the conference room together, they had higher synchrony. We have a number of post hoc potential explanations for this result. First is the cultural signals of a garage and conference room. One may associate a garage with informality and individualism, and a conference room with formality and conformity. Second, there are a difference in heights between the two rooms. One may associate a high ceiling with smallness, and therefore encourage a reduction of risk. Third, the conference room had a large window from which a city could be seen. Fear of heights is easy to elicit in virtual reality, and this potentially influenced participants' arousal and in turn their behavior. Ultimately, the factors influencing this difference in synchrony are unclear, and we plan to further explore the effective environment on behavior using VR due to its flexibility and replicability compared to physical environments. One new opportunity the analysis of triads provides is the ability to separate the dyads, especially into time-dependent categories. For example, at any given time, are the two dyads involving the speaker more synchronous than the non-speaking dyad? However, this question is not straightforward. Suppose we have some motion data over a period of interest. The full duration has a positive correlation, as indicated by the positive slope. But now suppose you want to ask which portions of time contribute more to that moment's synchrony, and you divide the two sets of time in half. We find that somehow both periods of time were not synchronous. This is precisely Simpson's paradox. This doesn't seem to fit with an intuition of synchrony as something that grows and shrinks over time. So to avoid this problem, we first normalize to mean 0 and variance 1 across the entire session, then take the average of the element-wise product across the duration of interest. This is the compositional measure of synchrony we are looking for. To our knowledge, this time segmentation of correlative synchrony is novel, and it has enabled us to study synchrony in relationship to speaking and gaze behavior. So let's return to that original question. Are the two dyads involving the speaker more synchronous than the non-speaking dyad? We computed synchrony for each pair within each speaking turn, and ran a mixed effects model predicting the synchrony from whether the dyad involved the speaker, with a random effect of triad and dyad within triad, weighted by the duration of the turn. Surprisingly, we found that synchrony was higher between the two non-speakers, as opposed to the speaker and listener. We considered two potential explanations for this effect. Based on interpretation of synchrony as mutual interaction, one might be able to claim that the two listeners were interacting more with each other than with the speaker. While it is true the listeners can and do communicate without speaking, it seems unrealistic to claim that interaction is stronger than the speaker's interaction. Second, synchrony could be the result of shared attention. If both listeners are attending to the speaker, and the speaker affects the listener in roughly similar ways, then there will be a correlation in behavior between listeners. Another way to explore the dynamics of synchrony is to look at synchrony dependent on gaze. It's reasonable to expect that there is higher synchrony in moments where a teammate is looking at another teammate. So like before, we break down the moments of synchrony into two categories depending on gaze. There are a couple ways to operationalize looking at, but across a wide range of these parameterizations, it appears that synchrony is higher when two people are not looking at each other. This is certainly unexpected, both in terms of mutual interaction and shared attention theories of synchrony. We have one potential post hoc explanation, which is described further in detail in the paper, but in short, moments in which one participant is looking at another are more likely to be moments in which the looker is not moving very much and the target is moving a fair amount. These kinds of moments have negative synchrony. Wrapping up, in our work we show synchrony happens in VR, synchrony happens in triads, location may affect synchrony. Synchrony appears higher among listener-listener pairs, as opposed to speaker-listener pairs, and synchrony appears higher in moments where participants aren't looking at each other. As always, you can read the paper and its works cited for more information. Finally, I look forward to speaking with you about the paper during the presentation time and beyond. Thank you.